What are Java streams? Java Stream API is used to process a source of data. A source of data here can be a collection of object or any primitive array or any input-output channels basically. A stream is basically a sequence of objects that supports various methods which can be plugged in together to produce the desired result. We should not get confused between stream and data structure, because data structure is something which stores a data and stream is basically what takes inputs from that collection or from that data structure. An operation on stream produces a result, but it does not modify the original source of data. So basically whatever stream we are taking out of any collection, it is working on a copy of that collection. It does not modify the original source of data. Let us look into this example. We have an array of strings, and what we are getting here is we want to get those strings which contains the E as character, and the length of those strings should be greater than 5. Okay, and then we are mapping it to the uppercase, and then we are counting how many such strings are available. So if you can see here, we are getting a stream out of those strings using arrays.stream, which basically is our source of data, right? So stream has three components. The first component is source of data, on which we are doing some operations, right? The next second method which we have defined here is which are basically searching for those strings which has E character in it, is a filter method. Similarly, third one is also a filter method which is searching for the strings which are greater than 5 in length. And the third is a map function or a map method which is converting those strings into uppercase, right? All these three methods, two filter and one map, are known as intermediate operations, right? So we are working on a source of data. We are performing some operations on the source of data via intermediate operations. So these intermediate operations will always result into another stream, right, which can be fed into another intermediary operation, or the next step basically. The last step in here is the count method, which is a terminal operation. So any stream will have three component. One will be the source of data. Second, it will have zero or more than zero intermediate operations which will result into another stream. And the third is terminal operations. So the stream can only have one terminal operations which marks the consumption of a stream. So as soon as the terminal operation is performed, the stream is said to be consumed. We cannot go through that stream again. We have to get another stream if you want to work on further. So the terminal operations marks the consumption of a stream. Let us look into this example here. We have a list of widgets. Widget is basically having three attributes. It has a color, it has a weight, and it has a shape, right? So we have red, blue, green colored widget, and we have different weights associated to it, and all of these widgets are circle in shape. So we have a stream created from this widgets which is filtering the widget based on the color, and then it is mapping those widgets according to its weight, and then we are sorting those weights, those integers basically, and then we are collecting into an array. So here this stream widgets.stream is basically the source of data. Filter, map to int, and sorted are intermediate operations, and this two array is basically the terminal operations. All right, so we have a list of widgets here. We are getting a stream out of it, and we are applying a filter method here, which is the intermediate operation, which will filter out these widgets based on the color. It will give us all the green colored widgets. So this method will result into a stream of green colored widget. The next method is map to int method, which will take the output of this filter method as the input, and that input will always be a stream, because intermediate operations always result into a stream. So what it will do is it will map these widgets into its weight, right? So it will extract the weights out of these widgets, and here we have 6, 8, and 1, which are the weights of these widgets. These weights are also stream, which will be input to another method, which is a sorted method. What it will do is it will sort these weights into ascending order, and it will give us 1, 6, 8. Now this stream is fed to another operation, which is a terminal operation here, which will collect all these weights into an array. If you look step by step, the first step was to get the source of data. So we are getting the source of data from the list of widgets. Then the next step is we can have zero or multiple intermediate operations. So in here, in this particular example, we have three intermediate operations. One is to filter the widgets from by color. So we are getting the green colored widgets. then we are extracting the weights of those visits, and then we are sorting those weights. Right, so these are the three intermediate operations we have in this example. And the next step is the terminal operations, which will mark the end of this stream consumption, which will collect all the data into an array. So we have an array here, and we can perform multiple operations in it. So these are a list of intermediate operations which Java provides. We can do a filter of it, so we can filter any element based on some condition or some predicate. Then we have a distinct method which will gives us a stream which have all the distinct element, so it will remove all the duplicates. Then we have a limit method which will limit the infinite or the long stream into a finite value of stream. So for example, in this case it will limit to just three elements. Then we have skip method which will skip the first n number of elements, and it will give the stream of the next n elements, right, after skipping those first n elements. Then we have a sorted method which will sort a particular list of a particular stream of data into given comparator, right? So if we provide any comparator, then it will sort based on that comparator, or it will by default sort in ascending order. Then we have a map function which will do some operation based on the condition or the predicate which we give in the argument. Then we have a boxed operation which will convert the primitive type to its wrapper type. Then we have multiple terminal operations available. So these are the common min, max, average, count, and sum function which are available as part of stream API. Apart from this computational method, we also have for each, which will just take the stream of data and it will do some operation on each of the element of that particular data. Then we have to array to collect stream of data into an array. Then we have collectors dot list to collect stream of data into a list. Then we have any match method which will return true if any of the number matches the predicate. And we have all match method which returns true if all of the stream of data matches this particular predicate. And then one of the most important terminal operations which Java Stream API provides is the reduce method. So we can do multiple operations on a stream of data, and then we can reduce those data into a single value by giving some binary operation as the argument. So here, as you can see, I have given the sum operation as an argument. So what it will do, it will traverse through this number array, and it will sum all of the element of this array, and it will provide us the value of it. Now let's look into this example wherein we have a string of array and we want to find the longest string out of this array. So what are the approaches available we have? The first approach can be very simple, using a loop, right? We can define a string with an empty string, and then we can compare that string through each of the string element present in that array using a for loop, right? And once we get a longest string, then we will replace the variable longest with that particular value of that element. The second approach can be a recursive approach wherein we can define a recursive method which will take string array as an input and the index as an input, and predefined string variable as an input, right, which will hold the longest string value till now. And this recursive method will hold the logic of finding the longest value. Even in the recursive way, we have like plenty of lines of code, right, just to find the longest string out of an array. So what can be the third approach? So third approach can be using streams, right? When we have the feasibility of using streams, then we can make use of it and we can reduce the lines of code, as well as we can adopt a functional style of programming which is more readable and more elegant way of writing code, right? So we can get a stream out of this string array. Then we can use a reduce function which we just discussed earlier, that this is a terminal operation. So we can use this reduce method. We can pass in the parameter, the two parameters which will be like basically x and y. So what it will do, it will compare the length of x with the length of y, and it will return whichever is greater, right? So and at last we can call dot get to get that result out of it. So this is an approach wherein we can use the stream API, but this is not the most feasible or most efficient way of using streams, because still we have extra lines of code using this if condition. So why do all of these things if we have other inbuilt methods available, right? In the next approach, wherein also we are using the stream, we are getting a stream out of these strings, but instead of using the reduce and writing our own logic to compare the values, what we are doing here is we are using a max method, which is a terminal method, and we are passing in the comparator, right? So we are passing in the comparator, which is the integer comparator, and what it will compare, it will compare the length of the string. So this will result the same value which this stream will result, but this has completed into just 3 lines of code, and this has taken almost 5 or 6 lines of code. So stream helps us write cleaner code and elegant code, as well as maintain the functional style of programming. There are two important methods in Java Stream API, which are map method and flat map method. Map method is basically to map a stream of data into something else, and a flat map is basically used when we have a list of objects. So in this example, we have a student object which has ID, name, and books issued. So a student can have multiple books issued to their name. So we have created a list of student object here, which has 5 different students with a 5 different student name and the list of books which they have subscribed to or they have issued. So what we can do here is, so if we let's say get the stream out of the student object, so students dot stream, and then if we do a map object, right, and what we'll do, let's say we are just getting the student dot get books issued, right, and then we are collecting it, collect collector dot to list. So what we are doing here is we are getting a stream of students object, then we are mapping based on their list of books they have issued, and they're collecting those list of books into a list. So what this will result, this will result into a list of books, right? So it will result into list of string, okay, which are books. Okay, so if we print this, what we'll see, instead of getting a list of books, we are getting list of books. So this, the outer list is having these inner list, right, which has the books corresponding to each of the student. But what if we don't want this kind of output? We want a flattened list which will only have books in a single list. So in that case, flat map comes handy. So if we stream over this student object and we use a flat map, what we will get, we will get a student dot get books issued, and then we have to use the streams. So as we can see in the map method, we got the list of books, right, this list. But when we use a flat map, what it does is it gets the books issued, which is the list of string, right, and then since it knows that it's a list of strings, so we can also apply a stream here. So once we apply a stream here and then do a collect, what it will do, it will just return us a list of string. Okay, and when we print this, we'll get the list of books, all the books of all the students, right? So we are not getting inner list, we are just getting a flattened list with all the list of books. So in this scenario also we can use let's say for example dot distinct method. What it will do, it will just remove the duplicate out of it. So book 1, then book 3 and book 2, it will just keep one instances of those books, right? So it will remove all those duplicate and it will give us a simple flattened distinct book. So what we can do, let's say if we do not collect this into a list, right, and then we are not printing it. Okay, so essentially what it will do, it will produce a stream out of the students, it will flatten that stream, it will get the distinct element from that stream, and it will collect into a list. We have a method called peek. So as the name suggests, peek means to look, right? So what it can do is it can go ahead and it can look into the stream and tell us what this stream contains, right? So if we do a peek of it, so as you can see, it has book 1, book 2, book 3 and this one. So it is basically reading the contents of the stream which is generated by these methods. In a nutshell, this is what Stream API is. So Stream API is a very simple API and it is very widely used these days. Even I use it almost daily in my day-to-day life. And you can convert a large piece of code block doing some operations on some collections. You can convert those into a simple piece of code blocks using streams, right? So streams are very helpful, very powerful, and very elegant way of writing your transformation logic into any collection. So I recommend you go and you try it out yourself in your IDE, and do post out any question you have regarding stream in the comment down below. Thank you. Signing off. Bye bye.